Okay, so we need to start a new topic now. It's called complex numbers. I'm sorry, we just finished complex numbers. I apologize. We need to start the topic called quadratic equations. Quadratic equations is what's next up. Okay, so here we go with the title, quadratic equations, and this is our first video on quadratic equations. Okay, so let me start off with with some explaining, a little bit of explaining before we even start a method of solving a quadratic equation. I'll put problem number one over here on the side, ready to go, to show you what we're up against, so to speak. X squared minus 3x minus 10 equals 0. This is a quadratic equation, squared, x squared, quad, x squared. There's an equal sign, so it's an equation. So when you see the x squared and you see the equal sign, and it's not above 2, but it's just x squared equals, so you know you're in quadratic equation territory. All right. Now, this happens to be a trinomial. We'll see a couple of different types of quadratic equations, but here's one with a trinomial. That's what happens very often. You get a trinomial, and you're supposed to solve it. Eventually, not yet, eventually, I want to show you a couple of methods of how to solve quadratic equations. Eventually, I have to show you the quadratic formula, but that's not yet. Right now, we're working on solving this quadratic equation by factoring. Solve by factoring. That's where we want to go. And now, before I even start the problem, I want to give you show you something very fundamental. Let's say you have x plus 5, in parentheses, multiplying x minus 2 equals 0, right? So, I go into this t. I'll be using this t. You do solving quadratic equations relatively often. And you go into this t and you say to yourself, let's think about this logically. How does a multiplication end up being equal to 0? Let's say you have a million, well, let's say, 1,000 on the left-hand side. If you multiply it times a 0, you'll get 0. Or if the first number is 0 and the second number is 1,000, you'll also get 0. So how does this wind up to be equal to 0? Either this is equal to 0, or this is equal to 0, or both are equal to 0. That's how it can wind up to be equal to 0. So how would this x plus 5 turn into 0 if there would be a minus 5 here? Minus 5 plus 5 is 0. How would this x minus 2 turn into 0? By being a positive 2 and a negative 2 would turn into 0. So here's how you use the t formation. Either x plus 5's got to be equal to 0, minus 5 on both sides, and we figure out that x has got to be equal to negative 5. Negative 5. Either x is equal to negative 5, and that's what blows this whole thing up. Minus 5 plus 5 is 0. The whole thing's blown up. Or x minus 2 equals 0, which means plus 2 on both sides. Or x, this is gone, x is equal to 2. Or x is equal to 2. 2 minus 2 is 0, and that blows the whole thing up. Or both of these things are true. That's what this little t does. That's what the logic dictates when you have a situation like this. All right. So if we want to solve a quadratic equation by factoring, here's what we do. Let's factor this trinomial. So we'd go to scrap paper. And we solve the riddle. What's the coefficient of x squared? Is 1. So we can do it the easy way. Just solve the riddle. All right. So put negative 10 a little bit to the right here. A times b has got to be equal to negative 10. And a plus b has got to be equal to negative 3. Got to be equal to negative 3. What are the magic numbers? A times b is negative 10, and a plus b is equal to negative 3. The magic numbers are negative 5 and positive 2. Negative 5 times positive 2 is negative 10, and negative 5 plus positive 2 is equal to negative 3. Those are the magic numbers. So we've got this factored. X with its own negative 5, x with its own positive 2, equals 0. Now we have the exact same setup as over here. It's not the same numbers, they're almost the same numbers, but they're not the same numbers. And now we go into this T formation, and we solve x minus 5 equals 0. That means plus 5 on both sides, x equals 5. Here's one solution to the quadratic equation. And over here, x plus 2 is equal to 0. Do minus 2 on both sides, and you get x is equal to negative 2. Here are the two solutions, and most of the time a quadratic equation has two solutions. There are the two solutions to the quadratic equation. Doesn't always have to have two solutions. I can show you one pretty soon probably that doesn't, but nevertheless, most of the time a quadratic equation has two solutions. How do you check it? You take the 5, put it back in here, and see if it all checks out to be equal to 0. And then you know that this solution is correct. Then you take the negative 2, plug it back into the original, see if this all turns out to be equal to 0, and you know that negative, if it does, then negative 2 is also a correct solution. They're not always both correct solutions. So you don't always have to solve, but sometimes it's very important to solve. I'm sorry, you don't always have to check your solutions, but sometimes it's very important to check your solutions. We can discuss that later. Okay, let's go to problem number 2, and let's practice it by solving. There's a little surprise in here, but nothing terrible. Let's say you're supposed to solve, might not say much more than just solve, x squared plus 12x plus 36 equals 0. Now, by the way, I'm going off on a little bit of a tangent here. Just bear with me for a second, but it's important. What if the problem was presented to you as follows? X squared plus 12x equals minus 36. What do you do then? We need the equal 0 for this thing to work out. To solve by factoring, you have to have an equal 0 on the right-hand side. You have to have an equal 0 on the right-hand side. You have to have an equal 0 on the right-hand side. But what if it doesn't? What if it's not presented to you that way? Very simple. You doctor it. Simply do plus 36 on the right, plus 36 on the left. What do you get on the left-hand side? X squared plus 12x plus 36. What do you get on the right-hand side? You get equal 0, and now it's ready to go. So just because it's not presented to you exactly correctly, you still are fine. All right, back to our problem. X squared plus 12x plus 36. This is a special case. This is the case. You can do it the old-fashioned way. You can do it with a riddle, but you might also notice that this is a perfect square trinomial. This is my scrap paper. Take the square root of x squared, and you get x. Take the square root of 36, and you get 6. Multiply it times 2, and you get back to 12x. It's a perfect square trinomial. So I know what the two things are. I know what I should do. I know how to factor this. The square root of x squared is x. The square root of 36 is 6. What do I put in the middle? I put a plus, and there's two of them. X plus 6 times x plus 6 equals 0. You go into the t, and x plus 6 is equal to 0. You set up x plus 6 is equal to 0, so you know the solution is 9 minus 6. Now you don't have to do it again. In this case, this is an exceptional case. It doesn't happen that often. You have an exceptional case where you have only one solution. You only have one solution to the quadratic equation. Most of the time, you have two, just like we had over here. Okay, so that is the beginning of quadratic equations, and we were dealing with, and what did we use? We factored the left-hand side, and that's how we got to our answers, our solutions to the quadratic equation. Let me show you some more types of quadratic equations, which would lend themselves to be done a different way. Let's move this up. And I have some room. Let me cordon off this area right over here and see if I can't get some work done in here. Here's another classic quadratic equation. Problem number 3. Problem number 3. X squared is equal to 64. Okay. Now, how do I get from x squared to x? They're not interested in x squared. They're interested in x. They're not interested in minus x either. They're interested in positive x. What's this the solution is when you find x by itself. How do I get from x squared to x? Here's how you do it. Take the square root of x squared. Take remember that invisible 2 in there? 2 divided by 2 is 1. you get down to just plain x. Whatever you do to the left side, you do to the right side. You have to take the square root of 64. And now it is crucial from now on when you're dealing with quadratic equations, when you're dealing with equations and you take the square root, you must write both roots. There are two solutions to this quadratic equation. It is plus or minus 8. Square root of 64 is plus 8. 8 times 8 is 64. And it's also negative 8. Negative 8 times negative 8 is 64. So there are two solutions to this. One of them is 8, and one of them is negative 8. That is the answer for x. They can be written on your answer sheet like this. It can be written on your answer sheet like this, 8 and negative 8. There are two solutions to this quadratic equation. That is very, very important. When you're dealing with quadratic equations, I know I'm being repetitive here. Then when you take the square root, you must take both. Your answer must have both roots there. Okay, let's get another piece of paper, if we can, if it works. Let's see. And now, okay, let's continue on. We're still dealing with quadratic equations. And let me show you, I think that was problem number 3. So I want to try problem number 4. And it looks like this. 2y squared, we got to be careful with some of these problems, they're a little tricky, plus 36 equals 0. All right, how do we handle a problem like this? Let's get, it's not a trinomial, we're not doing any factoring over here. We got to get the 36 to the other side. So it's not going to be a 36 anymore. Minus 36 on both sides. We get 2y squared is equal to minus 36, because I'm trying to isolate that y. I need that y. What am I looking for? I'm looking for y. It could have been x here, x squared, but I'd be looking for x. But now it says y there, I'm looking for y. All right, so if I'm looking for y, let's whittle it down to y. Minus 36 on both sides. I got rid of the 36 from the y side. I got to get rid of the 2 now. Divide by 2 on both sides. That's gone. I get y squared is equal to negative 18. Now I can do exactly what I did in problem number 3. I can take the square root of both sides. Take the square root and I'll get it down to y. That's what I'm looking for. I'm looking for y. If I take the square root of the left side, I got to take the square root of the right side. So this is equal to plus or minus. As soon as you take the square root, put a plus or minus, be very careful, minus 18. Plus or minus square root of negative 18. Now we know, got to go to scrap paper, we know that we've got to deal with square root of negative 18 and it turns into an imaginary number. So we got to clean that up and turn it into an imaginary number. So we've got to divide this into two parts, square root of 18 and square root of negative 1, just like we were doing before when we were learning complex numbers. 18 times negative 1 is negative 18. We're simplifying this. We're doing it on scrap paper. This becomes an I. This becomes two pieces, square root of 9 and square root of 2. Why is that? Because there's a perfect square there that I can handle, that I can use. What is square root of 9? Square root of 9 is 3. Square root of 2, there's nothing I can do about it. Then the I. And finally, putting it all together, put the I on the left-hand side together with the 3, I have 3i square root of 2. So what's the answer to this quadratic equation? Plus or minus 3i square root of 2. Problem is over. It's all reduced and simplified and cleaned up. We end this video here.